Okay, in this video I'm going to work the problem that I worked just a moment ago, which is the cantilevered beam, end loaded, and I want to calculate the deflection at the end. But in the earlier problem, I used the naive definition of Castigliano, which says write an energy equation, and after you finish the energy equation, take the partial derivative of the energy with respect to the load to get the deflection. And so I called that one the energy first method. Write the energy, then take the partial. This one I call the partials first method. What we're going to do is we're going to write the moment, and we will take the partial derivatives of the moment equations, which is the primary energy in a long beam, is energy due to moments are bending. And so we'll take the partials first, and then we'll do the integration. So we'll never actually have the energy. We'll go straight from an integral equation with moments and partials right into deflections. And so this is copied out of my notes. And so it says, read this carefully, so I will. It says, in performing any integration, it's generally better to take the partial derivatives with respect to the load F sub I first, meaning before doing the integration. This is true especially if the force is a fictitious force Q, since it can be set to zero as soon as the derivative is taken. We don't have to wait and do the integral first before we set Q equal to zero. So this is demonstrated in an example. That's all fine. Now here are the definitions of not energies, but deflections. So the partial of energy with respect to F is our integral, but this used to be, I'm sorry, I'm talking about tension compression load. I want to go to bending. Okay, the energy was 1 over EI m squared dx, and there was a 2 involved as well. So when we take the partial of that m squared, what we're going to get, the partial of m squared is m times the partial of m with respect to F. And so we can write it in this form, and I'll be ready to answer questions about this in class as well. But we can take our partials first, then we do the integration, and we never actually have the energy. What we have is the partial of energy with respect to the load, because we already took the partial before we integrated, and that partial of energy with respect to the load is the deflection at the point of the load and the direction of the load. And so let's see how this works out. Just as in the previous problem, so I'll go a little faster on this one. The moment is a function of x is f times x. I've already explained the coordinate system from the earlier video. If you want to find out more about it, go watch the earlier video. So moment of x is f times x. Now, I want to take the partial derivative now, and I want to take the partial derivative of the moment with respect not to x. I want to take it with respect to f, the load. So I'm calling this variable dm df is x. So dm df is x. And now we're going to apply this form of our deflection equation that includes the bending term only. And so this is going to be an integral from 0 to L of the moment, which is fx, multiplied by the partial of the moment with respect to f, which is x, is the x term. All of this was over EI, integrating dx, and we're of course integrating 0 to L. And this becomes, when I multiply fx times x, I get fx squared on the integral, and then the integral of fx squared over EI is fx cubed over 3EI. And I'm going to evaluate this integral, this term, between 0 and L, and that's going to give an FL cubed over 3EI. It's exactly the same deflection that we got in the earlier Castigliano. Certainly it's the same deflection that we would find in the back, in the appendix of the textbook for a cantilevered beam. And so this was a slightly simpler problem in that we took the partial earlier and it made the integral just a little bit easier. Maybe not a lot easier on this one, but a little bit easier. This is not an example where we had a fictitious or dummy load that we were planning to set equal to 0. We will see that illustrated in the next problem, and that's where taking the partial first, okay, taking the partial first inside the integral, and then setting the fictitious load equal to 0 before we integrate, before we do any other algebra, will be a real payoff. So we'll see that in just a second. or not in just a second. We'll see that in the next video.